Hello everyone, this is Mr. Shin. I'll be your AP Chem problem solving course instructor for Winter Boot Camp and IVYED. So this course, as you have been advertised, will be focusing mainly on how to approach a problem, how to solve each of the either multiple choice or free response very fast, very efficiently, and very accurately, correct? So I'll be guiding you how to approach each of the problems. And next slide, I will be showing you how this class is going to look like. Okay. So this is a class overview. So as I've said before, this will be a problem solving focused course. So which means that we'll be covering a lot of practice problems that I'll be assigning you. And I'll be teaching you how to approach each type of problems very efficiently. So for this course, I won't be going over a lot of concepts, but I will be giving you a brief overview of the class materials. For example, if I'm assigning you electron configuration for next homework, then I'll be going over important key concept. I'll be going over like some of the few practice problems. Okay. And I won't just throw you guys out there and solve this by tomorrow or Wednesday. I'll be giving you enough class materials to effectively solve the materials. Okay. So I will be posting a lot of summary or chapter notes online. So you guys can look at those notes and prepare for the problem solving class. Okay. And homework will be assigned at the end of the class, usually the material that I have just briefly covered during the class. Okay. So with that said, so class will look like, let's just say you have 2-hour class. Then first 30 minutes to 1 hour will be reviewing the homework. For example, let's just say I assign electron configuration for homework. Then I'll be going over and asking, oh, how did you guys do? And then you'll be giving me like, okay, I got this wrong. Then I'll be covering those materials in the beginning of the class. I'll be reviewing those wrong questions. And I'm gonna probably spend 30 minutes to 1 hour reviewing those class homework assignments. And then second hour will be covering the new chapters. Okay. So in case you're curious about the class structure, that's how this class is gonna look like. And it'll be at a very fast pace. So because I have to cover the whole entire chemistry curriculum in 1 month. But don't worry, I'll be giving you enough materials and covering very important ones so that you understand. So you don't have to worry that much. Okay. So let's dive into stoichemistry. Some of you guys have covered this class maybe at this point of semester, or some of you maybe just starting this. I didn't want to do a demo on a class on a subject or on a chapter that you haven't covered yet. So this is how my class is gonna look like. I'll be preparing like a lecture slide materials where I can just go over here, the class materials, and I'll be assigning you based on the class lecture slides. Okay, this is how my class lecture is gonna go. Okay. So for typical stoichemistry problems are very abundant in AP type of questions, and it's also one of those most easiest one. But also this is very basic and you have to know how this works very solidly. Otherwise, you'll probably get most of the questions wrong here. That's why I just wanted to kind of review this concept with you guys. Okay. So for gases, conditions are in SAP, and you'll be probably given one of the substance, and you'll have to find the other substance. For example, you'll be given, for example, how many moles of oxygen will react with this much of sodium. So you're given sodium amount, correct? Then you have to find how many moles of oxygen will be needed to react with this, correct? So you'll only be given one side and find the other one, or you could be finding efficiency, how many percent will be yield, stuff like that. So with that said, let's dive into the practice problem that I prepared for you guys. Okay. So how many oxygen will react with this amount of sodium? So this equation typically will not be given, okay? So you will have to do it yourselves here. So let's just say that we know that sodium oxide formula here, and then we balance these things out, okay? And the first thing you have to do is, what do you have to do first? First, you have to write the given values, correct? And then we know that we have 4 moles to 1 mole ratio, correct? For 4 moles of sodium, we're going to use 1 mole of oxygen. Is that clear? Okay. And that gives us to cancel the sodium guys out. And then we know that for 4 moles of sodium, you're going to use 1 mole of oxygen, correct? So how many moles of oxygen? So then we know that it's 4-to-1 ratio, correct? So if you have 16.8, then you're going to use 1/4 of this oxygen to react to get 2 sodium oxide here, correct? That's why we get 4.2 moles of oxygen here, okay? Next one. At STP, how many molecules of oxygen will react with? 632 decimeter cube. So decimeter is the same thing as liter, so I just put like a liter here of butane, okay? So a lot of AP questions, it's really convenient if you actually memorize like a hydrocarbon, for example, like methane, butane, propane, pentane. If you know that formula by memorized, then your test will be so much easier, okay? So at SCP, how many molecules of oxygen will react with this? So let's start with what's given here, correct? And then first, let's balance this equation out. So we have butane and oxygen here. So any type of hydrocarbon or combustion reaction, it'll yield carbon dioxide and water, correct? So then you have to balance this guys out, correct? Let's balance this really quickly here. So first thing, I like to use carbon to balance it because those are carbon is the least involved element here. So let's put 4 here and the 1 here. So now carbon's balanced. Let's move on to hydrogen here, okay? So then hydrogen, there's 10 here, put 10 here. However, what's the issue here? So there is 13 oxygen on the right side, but there is, you have to make this 13. However, you cannot have a fraction as a coefficient, correct? So what you can do is you can multiply the whole equation by 2 so that you can have 13 here. Make sense? So now you have 26 here, you have 26 here. Okay, so now we have completely balanced this equation out. So let's now get to the heart of this problem here. Okay, so you're given in liters, correct? So when you're given something in liters at SCP, so we have to use this equation or the fact that 1 mole of ATP in 1 mole of STP will occupy 24.4 liters of substance here. So 1 mole of this at SCP will occupy 22.4 liters of carbon or butane, correct? So we know that now we have converted this guy into, now we have just moles, correct? Okay. So now all you have to do is, they're asking for oxygen, correct? Oxygen, not the butane, correct? So we know that it's 2-to-13 ratio. Let's use that, okay? For 2 moles of this, we have 13 moles of oxygen. Is that clear? So now we use this, and now we can get the final moles amount of oxygen. So after we find out the mole amount of oxygen, we just have to convert that to molecules, correct? So then to convert that to molecules, then we have to use this Avogadro's number here. Is it clear? So 1 mole of oxygen will contain 6.02 times 10 to the 23 molecules of oxygen. Okay. So if you just multiply 632 divided by 22.4 times 13 times this will give you this answer, correct? But what if they asked you how many atoms of oxygen? How many atoms? Then this is a molecule, correct? So all you have to do here is there's one more conversion here. So you have 1.10 times 10 to the 26 molecules of oxygen. It will contain 2 atoms of oxygen in 1 molecule of oxygen, right? So you just have to multiply by 2 here, and you get this answer. Is that clear? Pretty easy, right? Okay. Next one. How many grams of potassium will react with 465 grams of nickel phosphide here? Okay. So here, nickel 2. This means it'll carry a +2 charge. Is that clear? So what kind of formula can we kind of formulate here? They didn't give you anything, right? So look at the periodic table, and you can quickly identify that phosphide will carry -3. Okay, so we can do a quick trick here, quick balancing trick here, correct? Then we can get to nickel 3 and phosphide 2, correct? So nickel phosphide, we can get this formula pretty quickly. React with potassium, correct? So we can just write it like this, correct? And then this will react to become nickel and potassium phosphide here. So let's give it a little quick balancing here, okay? And let's get to the actual stoichiometry here, okay? So they gave you nickel phosphide. So first thing we have to do is, these are all in molar ratios, correct? So the 6:1 to 3:2, right? So we got to convert this into moles first, okay? So I did this in our head. So 1 mole of nickel phosphide will have 238 grams of nickel phosphide, okay? So that's going to convert this into how many mole there is. Is that clear? And then cancel that out, and then we know that there is 1:6 ratio here, correct? So 1 mole of this has 6 mole to react with potassium. Is that clear? So now at this point now that we converted, now we just have potassium moles, correct? After that, what do you got to do? Just convert the potassium mole into molar mass. That'll give you the grams of potassium. Is that clear? Okay. So a lot of concept that student may find it pretty confusing is limiting reactants. Okay. So as long as you follow this tip here, you guys won't ever be confused. So limiting reactant is what? The reactant that runs out first. So everything kind of depends on the limiting reactant here. Okay. Because once you run out of limiting reactant, there's nothing to react with, correct? Right? So it has to react together. If one of the component runs out, then you cannot do anything, right? Is that clear? So any reactant that you don't run out is excessive reactant here. Make sense? Okay. So how to find the limiting reactant here? So for the generic reaction, let's say RA/RB equals P. So assume that amount of RA/RB is given. Should you use RA or RB in your calculation? So what that means is that, so let's find how many mole there is, right? And then divide by each coefficient in a valence equation. And you compare which one has the smaller amount here. So let's do that in practice, okay? So how many of hydrogen gas is formed? Okay, so let's see. So you have two, oh, I guess this is all given. 13 grams of hydrogen, and you have 80 grams of oxygen here, okay? So to follow the first step, what do you have to do? Find the moles of each guy, correct? Yes? So when you find the moles of each guy, you have 13 and 80 here. Hydrogen is easy, right? So you just have to divide it by 2 here, and you get 6.5 moles of hydrogen, correct? You have 80 grams of oxygen you have. 32 grams of oxygen per 1 mole, correct? So that gives us, what does it give? So you just divide it by 32 here, you get 2.5 moles of oxygen. Make sense? So that's what we have, right? So after we do that, what did the previous slide do? You have to do divide by the respective coefficient, correct? So we have this, and we will divide it by 2 because there's 2 here, right? Right? Okay. And then you'll do divided by 1 because there's 1 here, right? And you get 3.25 here, 2.5 here. Which one is greater? This is greater, right? What does that mean? Linear reactant goes to oxygen. Is that clear? So there's more hydrogen here than oxygen, which means oxygen is the linear reactant here. Okay? Is that clear? Okay. Oxygen is the linear reactant. So, okay. So that means that we have to rebalance. Okay? We have to rebalance the whole thing, just knowing that oxygen has 2.5. All right? Which means how many ratio is that? Oxygen is 1:2 ratio. Is that clear? Oh, sorry. How many of water is formed? It's still the same ratio. So there is 1 mole of oxygen used, and you get 2 water here. Is that clear? So you're going to use 1 mole of oxygen. It's going to generate 2 moles of hydrogen here. Okay? Okay? Cancel out the oxygen. And then all you have to do is convert the mole to molar mass. Is that clear? So this will give you the hydrogen moles, and you just have to multiply by the molar mass of hydrogen to get to actual grams here. And canceling that out, you get 90 grams of hydrogen. Sorry, water. Okay, so let's do one more practice problem here. At SCP, what's the limiting reactant? Okay, from the previous slide, do you guys remember? At SCP, 1 mole occupies by what? 22.4 liters. Yes? Okay. Let's keep that in mind before we do this. So we have 2 to 3 grams of that. We have this much of this. So first thing first, convert that into moles, correct? You have to convert that into moles. And you convert the chlorine gas into moles as well. So you have 4 moles of this, 8 moles of this, okay? Don't worry about this coefficient. They're like a little confusing. So only thing you have to do is divide this by this coefficient, divide this by this coefficient, okay? Let's go ahead and do it, okay? So when you do that, what happens? You get 2 and then 2.66. So which one is smaller? Iron is smaller. Is that clear? So iron is the limiting reactant here. Okay? So then we have to rebalance this whole thing using the mole value of iron. Is that clear? Yes? Okay. Then let's just use the mole value here then. Okay. So we have 4 moles, correct? 4 moles here. Okay. And then how much of that used? So 4 moles used, but we know that it's 2 moles per 2 moles, correct? So let's see. We have 2 moles of iron will produce 2 moles of iron chloride. Is it clear? Okay. Cancel out the moles here. We cancel out the moles here. And then after that, you have, what do you have here? After that, you have to now just convert 1 mole into the molar mass here by using this. And you get, what do you get here? 649 grams of iron chloride here. Okay. So I prepared more slide, but I think I'm just gonna cut it out here. So this is pretty much the overview of the whole bootcamp's gonna look like. I'll be using a pretty similar slides, and it'll be pretty clear for you guys to understand. Okay. So if you really like this that little demo, then I'll see you guys in the bootcamp. Enjoy the rest of the semester, and I'll see you guys later.